Building on the experience from the preceding data understanding phase, the second phase of the CRISP ML process aims to prepare data for the following model engineering phase. However, data engineering isn't a static phase, and backtracking circles from later stages are necessary if, for example, the modeling or deployment phase reveals problematic data. Feature engineering is modifying or pre-processing the input to a model, such as neural network, to make it easier for the model to produce an accurate result. The first task in this stage is selecting data. Selecting a good data representation based on the available measurements is one of the challenges to ensure the quality of the machine learning application. It's best practice to describe underutilized features or attributes as they provide little to no modeling benefits but offer possible loopholes for errors. In addition, the more features are selected, the more samples are necessary. Intuitively, an exponentially increasing number of samples for an increasing number of features is required to prevent the data from becoming sparse in the feature space. This is termed as the curse of dimensionality. Thus, it's best practice to select just the necessary features. Feature selection methods can be separated into three categories. Filter methods, which selects the features from data without considering the model. Wrapper methods use a learning model to evaluate the significance of the features. And embedded methods that combines the feature selection and the classifier construction steps. However, the selection of the features shouldn't be relied purely on the validation and the test errors, but should be analyzed by a domain expert as potential biases might occur in data. In such cases, explanation methods could be used to highlight the significance of features and analyze from a human perspective. The next task is cleaning data. The data might have a missing data or outliers. Missing data can be, for example, attributes that are null. A data specialist can understand why some data is missing and take them out or fix the missing data. Outliers are data points that are significantly different from the rest of the data set. Again, a data specialist can understand why some outliers exist and either take them out or fix them. The third task is data construction. Constructing features is a crucial step in machine learning where new features or new samples are created from the available data. It involves creating or combining the existing features or data, transforming them, or creating new features or data that better represent the underlying patterns in the data. This can be done in two ways: feature engineering and data augmentation. In feature engineering, new features could be derived from the existing ones based on a domain knowledge. This could be, for example, the transformation of the features from the time domain into frequency domain. In data augmentation, new data is created based on the existing data, such as by switching the scenery from a sunny day to a rainy day. This expands the data set with additional samples and allows the model to capture those invariances and improve the generalization capability. The last task is normalizing data. Normalizing data involves scaling the input data to ensure that all features have a similar range and distribution. This helps prevent bias in the model towards features with larger values or ranges. This process ensures that each feature has a minimum value of 0 and a maximum value of 1. One of the most common normalization techniques is called min-max scaling.